So the new topic is what? Alkali metals. Alkali metals. Okay. So in this alkali metals, what are inorganic chemistry? This lesson comes under what? Inorganic chemistry. In inorganic chemistry, we have what? Different types of chapters like what? Alkali metals, alkaline earth metals, and different types of what are things will be there. Just a minute. Yeah. So our new topic is what? Alkali metals. So alkali metals belong to which group? Huh? Group 1A, Roman number 1A in the periodic table. So why they are called alkali metals? These metals, when they are dissolved in water, when these group elements are dissolved in water, we get what? We get alkalis. Alkalis means what? Bases. Alkalis means bases here. So here they are what? Now group 1. Otherwise, Roman number 1A, you say. Okay. So next. So what are the group 1 elements here? Lithium, sodium, potassium, rubidium, cesium, francium. So lithium, sodium, potassium, rubidium, cesium, francium. And atomic numbers, how to get here? By adding magic numbers we get. To the atomic number of 3, we add what now? 8. 8 is the magic number. So 3 plus 8, how much? 11. To this 11, what we add again? Again 8 will be added. So 11 plus 8, how much? 19. Plus 18 we add. 18 plus 19, we get 37. So plus again 18 we add. 18 plus 37, 55. Plus 32 we add. 32 plus 55 is 87. So in this way, 8, 8, 18, 18, 32 are called what? Magic numbers. What are these called? Magic numbers of which group? Group 1. Okay. So group 1 means what now here? IUPAC group number 1. IUPAC group number 1. IUPAC group number 1 is also called what here? It is also called group 1A. Whole notation is 1A. So the name of scientists who discovered what these elements. Names of scientists not necessary, but I will send you the PPT. Just you go through the names. That's all. Next. So lithium electrons, how many there here in lithium atom? 3 electrons will be there. But 3 electrons, what will be electronic configuration? 1s2, 2s1. 1s2, 2s1. 1s2 is nothing but helium here. 1s2 is nothing but helium. So 1s2 and 2s1. So what is outermost electronic configuration here? 2s1. Outermost electronic configuration is what? 2s1 for lithium. So the general outermost general outermost electronic configuration is what? Ns1. N is what? Orbit number, outermost orbit number. Valence shell number. Outermost orbit number is N here, Ns1. So for lithium, what is outermost orbit? Second orbit. So 2s1. For sodium, outermost orbit 3, 3s1. For potassium, which orbit? Fourth orbit is outermost orbit. So 4s1 is outermost electronic configuration. So like this, what? Helium 2s1, neon 3s1, argon 4s1, krypton 5s1, xenon 6s1, radon 7s1. So like this, we get what now? Electronic configurations. Electronic configurations of these first year group elements. So for all these cases, in all these cases, what is the outermost electronic configuration? It is what now here? Ns1. Ns1 is outermost electronic configuration. Is that clear? So it's about what? Outermost electronic configuration of this one. Then occurrence. So alkali metals are very reactive. They are highly reactive and thus found in combined state. Combined state means in the form of compounds. In the form of compounds. In the form of compounds, they will be available. So as compounds, they will be available because they react with any element which is available and form compounds. And some important ores. Ores means what? Minerals. The important ores, important minerals. The important minerals are called what? Ores. The important minerals of metals are called ores. Okay. So the important ores of alkali metals are given ahead. So I will send you the PPT. Just you go through the names of these metals. Okay. So now compounds of each and every element of alkali metals. So lithium, these are the minerals, and sodium, these are the minerals. So the name and formula you remember. If formula is not given, that is not important to remember. If formula is given, that formula remember. Example, chili saltpeter. Chili saltpeter is what? NaNO3. Like the Glauber salt. Glauber salt is Na2SO4 dot 10H2O. So like this, all the formula you go through it. I will send you the PPT. Then, so like this, potassium, minerals of potassium, rubidium, minerals of rubidium, minerals of cesium, all these things just go through later. Next, extraction of alkali metals. How alkali metals are extracted from minerals, from their compounds. Alkali metals means first A group elements cannot be extracted, cannot be obtained by the usual methods of extraction of metals due to the following reasons. Okay, due to following reasons, they cannot be easily extracted like other elements. Alkali metals cannot be easily extracted like other elements. Example, first point here. Alkali metals are strong reducing agents. They are strong reducing agents means what? Easily undergo oxidation. Easily undergo what? Oxidation. Easily undergo oxidation meaning what? Easily lose electrons. Loss of electrons is called oxidation. Na? Easily these elements will lose electrons, so they undergo oxidation easily. As they're undergoing oxidation easily, they act as which agents? Reducing agents, powerful reducing agents. Hence they cannot be extracted by reduction. As they are reducing agents, these elements cannot be reduced. They cannot be obtained by reduction process of their oxides or other compounds of these metals. From other compounds of these metals and from oxides of these elements cannot be extracted because they are also they are themselves what? Strong reducing agents. That's why they cannot be extracted by what? Reduction process. Okay. Next, being highly electropositive. Second point of these what here elements. So being highly electropositive in nature. Electropositive nature meaning what? Easily form cations. Easily form positive ions. Positive ions meaning what here? Cations. They can easily form cations, positive ions. That's why they have more electropositivity. Okay, they are highly electropositive in nature. It is not possible to apply the methods of displacing them from their salt solutions by any other element. Suppose here NaCl salt solution it is. NaCl salt solution. From this NaCl salt solution, Na cannot be extracted. Na cannot be extracted. Sodium metal cannot be extracted from NaCl salt solution because Na is powerful electropositive element, highly electropositive element. It cannot be displaced by other element. Sodium cannot be displaced. We cannot displace sodium from its salt. So that is another point. Next, the aqueous solutions, the solutions of salt solutions in water. Salt solution in water is called what? Aqueous solution. The aqueous solutions of their salts cannot be used for extraction by electrolytic method because hydrogen ion, H plus ion, is discharged at cathode. Cathode means what now here? Which electrode? Negative electrode. Cathode is what? Negative electrode. But cation is what? Cation is what? Positive ion. Remember, cation is positive ion. But cathode is what? Cathode is what? Negative electrode. This at negative electrode, H plus ions will be discharged, but not H plus ions will be discharged, but not Na plus ions. So here in NaCl salt solution, Na plus ions are there, H plus ions are there. In water, H plus will be there. In NaCl, Na plus will be there. So Na plus ions and H plus ions, both ions will be in this solution, NaCl solution of salt solution. Now these two will go to what? Cathode. Cathode is having which charge here? Cathode is having negative charge. To this cathode, both ions will go. Both ions will go to cathode. But which will be discharged? H plus will be discharged because it is less metallic. H plus is less metallic than sodium. So H plus will be discharged and hydrogen gas will be released here. At cathode, which gas will be released? Hydrogen gas will be released because H plus ions will be discharged. but Na plus cannot be discharged in the form of sodium metal. So sodium metal cannot be extracted by this method at cathode. At cathode, we cannot get sodium. What we get? H2 gas we get, because H plus ions will be discharged before Na plus. When Na plus and H plus both are available, which will be preferentially discharged? H plus ions will be discharged preferentially, because H plus ions have low discharge potential. H plus ions have what? H plus ions have low, they have what? Low discharge potential. Low discharge potential. They have very low discharge potential. As they have low discharge potential, they cannot be, means what? H plus ions will be discharged first before what? Na plus. So that's what they said here. So they cannot be cannot be used for extraction by electrolytic method, because hydrogen ion is discharged at cathode. Instead of what? Instead of an alkali metal ion. Alkali metal ion, what we have taken in this discussion example, Na plus we have taken alkali metal ion. This Na plus alkali metal ion and H plus ion, when they are present, which will be discharged preferentially? H plus will be discharged before what? Na plus. So that point mainly we have to understand. Okay. So as the discharge potential of alkali metals high, hydrogen has low discharge potential. Hydrogen has low discharge potential. Therefore, alkali metals have what? High discharge potential. However, by using what? Mercury as cathode. If you take mercury cathode, suppose, alkali metal can be deposited. And this alkali metal will combine with what now? Mercury. Then what will be forming? Sodium amalgam will be forming. Sodium amalgam. So if you take which electrode here? Cathode, if you take what now? Mercury. If you take cathode what? Mercury. What we can understand here? When we take mercury cathode, what we get here? Sodium we get. Sodium we get. But sodium will be combined with what now? Mercury. When sodium combines with mercury, what will happen, ma? What will happen there? Immediately, the sodium and mercury combine to form what? Sodium amalgam. That point keep in mind. Next. However, by using mercury as cathode, by using mercury as what? Cathode. By using mercury as cathode, alkali metal can be deposited. The alkali metal readily combines with what now? Mercury to form what? Amalgam. Which amalgam? Sodium amalgam is formed here, from which its recovery difficult. Its recovery is what? Difficult here. It means what now? Sodium recovery. The recovery of sodium will be difficult from NaHg. That point keep in mind. Next. The only successful method, therefore, is the electrolysis of their fused salts. Fused salt means what? Molten salt. Suppose you take molten NaCl. Molten NaCl is also called fused NaCl. In this fused NaCl, Na plus Cl minus will be there. No H plus now here. No H plus ions. Because water is not there now. Water is not added here. There is no H plus ion here. Only Na plus and Cl minus ions will be present in fused NaCl or molten NaCl. So usually chlorides, NaCl, MgCl2, from chlorides only we get. Generally, another metal chloride is added to lower their fusion temperature. Fusion means what now? Melting temperature, melting point. To reduce melting point. To reduce what? Melting point of this metal. Suppose sodium is there. To reduce the melting point of NaCl, suppose we are extracting sodium from NaCl, molten NaCl we are getting. Suppose to get molten NaCl, what we have to take first? Solid NaCl we have taken. This solid NaCl at one particular temperature will melt to give molten NaCl. Okay, now here this temperature, this melting point of this NaCl will be lowered. The melting point of NaCl can be reduced, lowered by adding what? Some other chloride called calcium chloride. The calcium chloride, another metals chloride, Another metal chloride will be added to NaCl to reduce the melting point of what? NaCl. To reduce the melting point of NaCl, we add another chloride of metal. Then what happens now here? NaCl solid will melt into molten NaCl or fused NaCl. From this fused NaCl, we get only Na plus and only Cl minus. Now only Na plus will go to cathode. Only Na plus will go to cathode, negative electrode. Now at negative electrode, Na plus ions only will go because H plus ions not there here, competition not there. Only Na plus ions will be discharged here. Then we get what now? Sodium is deposited. Sodium is deposited at what? Cathode. Sodium is deposited at cathode now here. Why? Because Na plus only is available cation here. In the molten NaCl or fused NaCl, only cation available is what? Na plus. H plus is not there. So this Na plus only will discharge at cathode to give sodium metal. See now this one. Fused NaCl. Fused NaCl meaning what? Molten NaCl. So this fused NaCl or molten NaCl, okay, on fusion, on melting. On fusion means what? On melting, we get Na plus and Cl minus. Na plus and Cl minus ions we get. Okay. Now what happens? You see, at anode. Anode means what? Positive electrode. Anode means what here? Positive electrode. So at positive electrode anode, what happens? The negative ions will go. The negative ions will go to anode because anode is positive rod. Okay. Now here each Cl minus has one extra electron. Minus 1 means one extra electron is there. 2 Cl minus will have 2 electrons extra. So 2 electrons will be lost. When 2 electrons lost, 2 Cl atoms will be combined to form Cl2 gas. So like this Cl2 gas is obtained at anode. At anode, what is produced here? Cl2 gas is liberated. Then these Na plus ions, cations, will go to what? Cathode. Because cathode is what? Negative electrode. Negative electrode is what here? Cathode. So at this negative electrode, which ions will go? Cations will go. The cations will be attracted towards cathode. And each Na plus is deficient of one electron. Each Na plus 1 is deficient of one electron. So each Na plus needs one electron to gain. 2 Na plus ions need 2 electrons. So 2 electrons will be gained to form sodium atoms, 2 sodium atoms. Here gain of electrons is called what now? Reduction. So gain of electrons is called reduction. So at cathode, what will take place? Reduction will take place. At cathode, which process takes place? Reduction takes place. And here you see at anode, what is happening? The 2 Cl minus ions losing electrons. The loss of electrons is called what here? Oxidation. Loss of electrons is called what? Oxidation. So at anode, always what will take place? Oxidation. So remember this one, OA. Bandagurtu remember. Bandagurtu means what now? Mnemonym. Mnemonym means what? OA. Overaction. Overaction. OA means what here? Oxidation, anode. So O for what here? Oxidation. Oxidation will take place at what? Anode. At anode always oxidation takes place. At cathode, what should take place now? Reduction should take place. At cathode, reduction will take place. At anode, oxidation will take place. So these points clearly to be understood here without any confusion. Okay, ma? Next. Alloys. Alloys formation. Alloy means what now here? The combination of two metals will give alloy. So the homogeneous mixture of two or more metals is called what? Alloy. The alkali metals form alloys among themselves sometimes. Means one alkali metal will combine with other alkali metal as well as with other metals. Other metals means what now? Sodium amalgam. Sodium amalgam is formed by the combination of sodium alkali metal with mercury. Next. Alkali metals also get dissolved in mercury to form amalgam. Here mercury is one metal. Mercury is one metal. Alkali metal is one metal. So alkali metals will combine with other metals like mercury to form what? Amalgam with evolution of heat. Evolution of heat means what? Exothermic or endothermic? Exothermic. So exothermic process. Whenever sodium metal or alkali metal combines with mercury to form amalgam, what happens here? Energy is released here. Energy is released meaning what? The reaction is what? Exothermic in nature. And the amalgamation means formation of amalgam, is highly exothermic process. Exothermic means heat is evolved. Next, the physical properties. So this week examination syllabus is up to physical properties. Remember, up to sorry, up to physical properties of alkali metals we have syllabus. Remember, physical properties. So there will be two types of properties: physical and chemical. This week examination is up to physical properties. Chemical properties will not be there. Now see here. So the physical state means what? Solid or liquid or gaseous state or aqueous state. Okay, so the solid, liquid, gas, these are physical states. So all are silvery white. All means what now here? Alkali metals. Alkali metals are what? Silvery white, and they are soft and light solids. Light means lightweight. Light in weight. Light in weight. So lightweight solids. They are having less weight. So lightweight solids, and they are soft, silvery white. These can be cut. These alkali metals can be cut with the help of knife. With knife, like a cake, we can cut what? Sodium. Okay. When freshly cut, when we cut the sodium metal freshly, they have bright luster. Bright luster. Luster means what now here? Shining light. Okay, luster means what now? The shining surface. So the brightness. So bright luster will be seen. So which quickly tarnishes. Tarnishes means what now? Becomes dull. Becomes dull. Okay, that means suppose you take here this one. If you cut the sodium, initially the cut surface will be having luster. Luster means what now? Shining surface will be there. It will be shining initially when you cut. Slowly it becomes what? Dull. Okay, that means the tarnishing takes place. Tarnishing takes place due to surface oxidation. Due to surface oxidation means what happens here? When you cut the sodium, this cut surface of sodium initially will be having luster, having bright luster. But slowly this cut surface has some atoms, now sodium atoms. That sodium atoms combine immediately with oxygen to form oxide, sodium oxide. That sodium oxide will not be having shining surface. It becomes what? Dull now. That is called tarnishing due to surface oxidation. And these means what now? First A group elements. First A group elements. The first A group elements means for alkali metals form diamagnetic substances. Diamagnetic colorless ions. So diamagnetic means repelled by magnets. Repelled by magnets. If any substance is repelled by magnets, that is called diamagnetic substance. If any substance is attracted by magnet, paramagnetic substance. If any substance is attracted, paramagnetic. If any substance is repelled by magnets, diamagnetic. So these form diamagnetic ions and colorless ions. So Na plus is colorless or colorful? Na plus is what? Colorless ion. So colorless ions will be forming, and Na plus ion has what configuration? 1s2, 2s2, 2p6. 1s2, 2s2, 2p6. Here 1s2 means what now here? One box. One box contains how many electrons? 2 electrons paired. And here 2s2 also one box with 2 electrons paired. Here 2p6. 2p6 what here? How many boxes? 3 boxes. 1, 2, 3, 4, 5, 6. All electrons paired. So in Na place, all electrons are paired. So when it will be diamagnetic substance, it will be if it is having all paired electrons. If all electrons are paired, if all electrons are paired electrons, that will be having diamagnetic behavior. So Na plus ion is having all paired electrons, no unpaired electron in the electronic configuration of sodium ion.